अपने घर की बात बताऊंगी। नहीं बट
We have our next resource person with us, Adanya Dr. Karan Mittal ji. Yesterday, day before yesterday, we had a very wonderful session of him, and we rightly know him with his very wonderful and mind-blowing session. So, without wasting time, I would like to request Dr. Karan Mittal ji to start with a wonderful session. Over to you, sir.
Thank you, Shreyas and again, once again, my thanks to World Yoga Center for giving me this opportunity to share my knowledge about exercise physiology with all of you. So, without much ado, let's begin with exercise physiology. So, what I have planned is, since I'll be also taking 2 sessions on nutrition later, so there would be certain pointers in this session as well as in the last session we had, which might fulfill their completion when we address the nutritional aspects of athletics or yoga and performance. So there would be certain pointers which should help you connect how physiology, anatomy, and nutrition can help you change or can make a difference in the performance of your fellow students. So let's begin with physiology. Last time we had an introduction to certain body systems. Today we'll go much more deeper into those body systems and how exactly when you perform exercise. So exercise is not normal resting state. So right now, last time what we discussed was the normal resting state of a human being and how the body systems work. But exercise is a state which is beyond the normal resting state. Of course, it's a physiological state in the sense, in layman terms, it is normal, but it is beyond body's capacity. So body makes certain adaptations to adjust itself to the increased requirements which happen during exercise. So today we'll be discussing those systems that are specifically affected because of this specific exercise routine, athletic performance, like you saw artistic yoga. So it's like high intensity exercises in a very short duration of time. So how does the body adapt to these changes? Today is my focus, and then later on we'll cover the nutritional aspects of sports nutrition. So let's start with the presentation. Yeah. So there are 3 major systems that are directly connected with exercise physiology. First is your respiratory system, second is your cardiovascular system, musculoskeletal system, and your nervous system. So the first 3 are of much more importance to us as yoga coaches. Now, respiratory system, because when you are exercising, all the muscles in your body are working to their optimum levels or at a higher level than the normal sitting posture or normal standing posture or walking posture. So they have increased requirements of oxygen. We'll be discussing these systems in detail. This is just a starter to the deeper discussion. So as for an athlete, this respiratory system kind of adapts over a period of time. It undergoes a specific change so that whenever that athlete goes into performance the next time, it is able to meet the demand and supply ratio of the oxygen, because in exercise the body demands much more oxygen. So the lungs and the respiratory apparatus all together kind of adapts. So now if you're like now if you we all are sitting, so our breathing is not very prominent. But a person who has just ran a marathon or who has just performed yoga for like 2 hours, and it's a high intensity yoga with little or no rest, you see that his whole body, when you see that this person, he is breathing heavily. Now how does that happen? Because the diaphragm we discussed last time, that is the major muscle of breathing in and breathing out. But apart from that, the body has also certain accessory muscles which become activated when you require more oxygen. So you'll see these muscles of the neck will move, the muscles of the chest which are between the ribs will move, so that it gets a more capacity, the lungs get more capacity to take in oxygen and to throw out carbon dioxide. So that's just a brief about the respiratory system. Then the cardiovascular system. Now, because muscles are working hard, working more, and working for a longer period of time, naturally their oxygen demand has increased, and also their demand for more nutrients has increased. So more carbohydrates are required to this kind of muscle. Plus, whenever there is a chemical reaction happening in our body and muscles are working, they also excrete lots of waste material. So that waste material also needs to be excreted. So this postman work, like we discussed last time, is done usually by the cardiovascular system. Uh, So the cardiovascular system also modifies itself so that whenever there is this increased need during the sports performance or during the training, then it is able to equip more and more resources to do this to and fro movement, supply of nutrients and oxygen to the muscle, and taking of carbon dioxide and waste material from the muscle. So like earlier, maybe 5 postmen were working for a muscle, then 10 people are recruited during the exercise time, so that this supply and excretion ratio doesn't affect the muscular performance. So these are the two systems. When we come to muscular system per se, specifically muscular system, then any muscle in your body, physiologically, there are 4 parameters that are required to determine how well functional this muscle is. First is the strength of the muscle. Now, in Yogasan students or people, the strength is of importance, but it's not of much importance, because the strength of the muscle directly determines the weight lifting capacity of the muscle. So if a gym goer is lifting 5 kgs on the first day and he keeps on increasing to 15, 10, 15, 20 kgs in the next 6 months or 7 months of the line, what is he doing? He's increasing the strength of his muscle to lift more and more weight. And the capacity of the muscle to lift the weight is directly related to the thickness of the muscle. If you remember, last time we had discussed that muscle is made up of those fibers, those copper wires which are running inside that thick muscle. So the more the number of fibers, more is the capacity of that muscle to lift weight. So suppose if a 5 centimeter thick muscle is able to lift 10 kgs, then a 10 centimeter thick muscle will automatically be able to lift 20 to 25 kgs. So thicker the muscle, more is the strength. Now for us, the strength of the muscle is not very important. It's important when you're doing poses which are anti-gravity, handstands and everything. So you should have muscles of the shoulders, etc., which are able to take the strength or the weight, bear the weight of your body. But in general, strength is not very important to us in Yogasana. For us, it's more about power, endurance, and flexibility. Flexibility, I'm sure there are teachers who are teaching you how to adjust asanas, how to make the body more flexible, how to open up the joints. So I'm not getting into flexibility, but flexibility is basically how far the muscle can stretch and sustain. So a muscle can stretch maybe when you're performing some asana like Ustrasana or something, then the front muscles of your abdomen is completely stretching themselves and going backwards. Okay, so how far they are able to sustain, that will determine how much curve you are getting in Dhanurasana or Ustrasana. So that is about flexibility. Then there is power. Power is how like if like now you saw this artistic yoga video, so the muscle is performing fast also, the muscle is performing flexible poses also, and the muscle is also doing it repeatedly. Like it's not that it's doing for a minute and it's stopping. That video was for approximately 6-7 minutes, so it is sustaining that performance for a longer period of time at its optimum functioning. So that is, and it is doing complex poses. So that is power. When you take all these parameters together, then it is power. And the last one is endurance. So as yogasan teachers or athletes, performing 1 hour, 2 hour, 3 hour, 4 hour, increasing your capacity from 20 minutes of practice to 2 to 3 hours of practice for athletic yoga, that is endurance. So endurance is directly the time. Now what we usually deal with is endurance and flexibility. Strength and power is of not much importance, but endurance and flexibility is utmost importance in yogasan kind of sports, because when we practice, our training sessions last for 2 hours, 3 hours, 4 hours. So endurance of the muscle should be high, and at the same time the muscle have to be flexible. Now if you have a very thick muscle, like if your biceps have because of too much of weightlifting, the muscles have become thick, then automatically the flexibility reduces. That's why if you see weightlifters going to gym, they're not able, their body is not very flexible. They are huge, they can lift heavy weights, but flexibility is reduced, because as the muscle becomes thick, then it doesn't have much space to move. So your limbs don't have much space to move. So if I can bend my elbow completely because my biceps has become huge because of weightlifting, then I'm not able to bend it completely, because there's a hindrance that disallows complete bending. So that was about the 4 parameters. So let's get into the physiology directly, the topic given to me. Now this, I'm just getting connected to the main parameters that define muscular performance. So the first is nutrient supply. Nutrient is the basic raw material that we require for energy, and we have discussed last time that the work of energy digestive system is to break down into those 1 rupee coins which my muscles can utilize directly. So two things we need to know over here. As teachers, we need to know two things, that there are two kinds of raw materials that my body can use as nutrient source or the source of energy. First is glucose. So glucose is like a firecracker. It will give immediate energy, it will give huge amount of energy, and within a minute or two it will just fall down. So it's like a firecracker. And there is second thing which is called as glycogen. Glycogen is like a lamp of ghee or oil that you have lit in your house during Diwali. It will give slow energy, the light will be less, and it will sustain for 2, 3, 4, 5 hours at a stretch. So both are energies, but these are different kinds of energy. So when the athlete is tired during competition, you give Glucon D because it's fast energy and it can make the athlete work for 1 hour, next 1 hour without getting tired. But when you are training an athlete for a performance, for a sports competition, then the focus is not glucose, the focus is glycogen, that your body should be able to use or to increase its storage reserve of this oil. Like if you take a small diya, it will light for 1 hour, the small lamp, and a bigger lamp will light for like 3 hours, 4 hours. So body's capacity to store this glycogen and use it at the time of need during a competition is our focus as coaches. So the diet and the physiology should be adjusted so that the glycogen, which is the storage form of energy, the capacity of the body to use and store that increases very systematically over your training periods. So you can just see this comparative chart. So athlete who's on completely high carbohydrate diet, this athlete can maybe perform for 240 minutes at a stretch because the carbohydrate that the athlete is eating gets converted into glycogen and it is stored in the muscle, which we'll be discussing now. If the athlete is eating mixed diet, then he or she can perform maybe for 120 minutes, where he is taking some amount of carbs, fats, and some amount of protein. But if the athlete is only taking high fat diet, okay, which is the case nowadays, people, because not knowing what exactly need to be taken, they are eating a carbohydrate source, but that has been flooded with too much of fat, and that too unhealthy fat like mayonnaise, cheese, and all that stuff. So the diet, instead of becoming a high carbohydrate diet becomes a high fat diet. So their performance automatically reduces because the fat is a secondary store of energy. It's not the primary source of energy. So you can just see the diagram on the right side. It gives a graph. I'll share the PPT. You can study this graph. So high carbohydrate diet athlete will automatically perform better as compared to an athlete who is on a high fat diet. Okay. So this carbohydrate, when you're eating rotis, when you're eating rice, when you're eating fruits, when you're eating any carbohydrate source, this gets stored in your body, in the muscles and in the liver, in something called as glycogen, which we just studied. So this is the storage form of carbohydrate that our body has. And this capacity, so earlier if the muscle was storing X amount of glycogen, then with proper training and with proper dietary modification, this can become 2x, 3x, 4x. It's like increasing the capacity of that lamp to last for 2 hours, 3 hours, 4 hours. So that is about glycogen. It is also stored in liver, but it is in a very small amount in liver. For athletes, basically, the main storehouse is the muscles. Let's move ahead. Muscles also utilize fat for as their source of energy when they are using carbohydrates. So consumption of healthy fats is very important in athletes as well, because when muscle is using energy, then it is the main source is carbohydrate. But at the same time, it requires some amount of fat for other metabolic purposes, which we are not getting into detail. So having healthy fat is equally important in an athlete, which we will discuss in the nutrition lecture. So eating walnuts, almonds, oils, or some amount of ghee. These kind of healthy fats are very important as compared to vanaspati fat and all that stuff, which are considered to be the lower quality of fats. Now, muscle glycogen also comes from the perspective that if you're like whenever you have performed for at an event, where your student has performed at an event for 4 or 5 hours at a stretch, so the storage which is there in the muscle of this glycogen is completely depleted. Okay, the muscle uses all its stored form of glycogen and performs and gives its best performance in that competition. And if the athlete after that competition is having a high healthy carbohydrate diet, then this replenishing the stores which have got depleted, to refill the stores again back to the normal level takes 2 days. This is a medical physiological parameter. There's no hypothetical numbers that I'm using in this site. Everything is from medical journals. So it takes 2 days. But in the case if the athlete is not taking a high carbohydrate diet after the competition, then it might take up to 5 to 6 days for the muscle to build up that glycogen store in the in its storehouse. So it's always advisable that once the competition is over and the athlete is back to its normal routine, for the first 2 days it should be a high carbohydrate, high protein diet. Fat, even if it's lesser, it's okay, so that the muscle starts repairing itself faster, and the athlete is again ready to train further for the next competition. So that is very important. And if you apply this same logic, now we deal with after the competition I just spoke about. If you apply the same logic before the competition, it is advisable that the athlete doesn't perform any high intensity workout for the 2 days prior to this competition, because if you are doing any high intensity workout, all the glycogen in the body will get used up for that performance or that high intensity workout, and body will take again 2 days to again replenish the store. So it is advisable that since we don't want the competition day to be compromised and muscles getting fatigued easily, for the first 2 days before the competition, high intensity workouts shouldn't be performed. You can go up with the normal flexibility yoga and practice of whatever rhythm or whatever you have set, but not doing any weight training, too much of running, too much of physical exertion. All these things should be avoided just before the competition. I hope I'm clear till here. Coming back to the respiratory system, so we got 3-4 key points in the nutrient part. Now coming to the respiratory system. Now when I'm talking right now, my body is taking 250 ml of oxygen per minute. But with proper training, especially in athletes who do long distance marathons or who are heavy weightlifters, this capacity can be increased up to 4,000 ml per minute. Because now yoga comes into moderate capacity workout, then a requirement of 2,000 ml per 2,000 to 2,500 ml per minute of oxygen is required when you're performing yoga back to back as a competition, not as a medical therapy, as a competitive realm to it. So that much oxygen is required. So you have to increase this capacity of your student from 250 ml of this normal resting state up to 2,000 to 2,500 ml per minute over a period of time. Now this can be increased, of course, maybe I'm just taking it, it's in the further slide, but now this can be increased by workouts that are high intensity for a shorter duration of time. So all your trainings routines, maybe in a week, twice or thrice, should include running, should include high intensity workouts, should include exercises which completely move all the muscles of your body, so that the oxygen requirement is increasing and the lungs are training themselves to take in more oxygen from the environment and supply to the body. So this should be a compulsion if you're looking at a competition 6 months down the line, twice a week, thrice a week, there should be some amount of high intensity, short duration workout in your students' regime. Pranayam is also a very high intensity pranayams like Bhastrika and Kapalbhati. Kapalbhati, of course, is a short term. So these pranayams are also, in researchers have proven that they increase the lung capacity of the person. In fact, it opens up many alveoli of the lung and increases the oxygen intake capacity. So this can be also an add-on to increase the oxygen supply capacity of your respiratory system. Now, whenever an athlete is performing, or whenever a athlete is doing a running or performing any competition, the muscles work under two pathways. One is called as aerobic pathway, which happens if oxygen is available, the demand of the muscle is supplied by the lungs, that is called as aerobic pathway. And second is called as the anaerobic pathway, when muscle requires more amount of oxygen, but the lungs are not able to supply that much amount of oxygen. That time anaerobic pathway becomes active and the muscles work under a no oxygen state or a lesser oxygen state. Now, if your aim is sustained physical activity for a longer period of time, like I mentioned yoga, marathon, etc. Then you have to work on the aerobic system of the muscles, where the demand of the muscles have to be met by the lungs. Okay, but if it's a short thing, if the person is running a 100-meter sprint or 200-meter sprint, all these short 1, 2, 3, 5 minute sports, so these kind of competitions, the muscles can survive for that first 2, 3, 5 minutes. On anaerobic pathway also can perform better. But the disadvantage of anaerobic pathway is this muscle produces a waste material called as lactic acid, and this lactic acid causes burning in the muscle, which you might have experienced, that when you're performing for a longer period of time, initial few days, and you take rest, then all the muscles start cramping and get into fatigue and can kind of get burning sensation. That is because the muscles are not getting enough oxygen during their workout, and muscles have worked up in a without oxygen environment. So that is anaerobic pathway. So our aim as teachers should be slowly increasing the capacity of our students to work more on aerobic pathway. That is, the demand of the muscle is met by the supply from the lungs. This should be our aim for better endurance, for a longer period of activity during training or in competitions. And as I said, that can happen with short duration, high intensity workouts, making as a part of your routine training. Cardiovascular system. Now, cardiovascular system, as I said, it's like a postman, it's like a delivery boy, and the main function is to deliver things here and there. Now, if you compare the blood flow in a normal vessel like mine right now, and a muscle of a marathon runner who has just come out from completing a marathon, the blood flow in that muscle is almost 25 times as compared to the normal blood flow. So right now, if it is getting 1 liter per minute, I'm just giving a hypothetical number, then when you are performing a high intensity workout, it is consuming approximately 25 liters per minute. So heart has to multiply its ability 25 times in high intensity workouts. So for people who train routinely, the circulatory system undergoes an adaptation. The circulatory system, the heart kind of, the number of muscles in the heart kind of increase. It undergoes hypertrophy, okay, to pump better, to push better, to take the stress of too much blood coming in and going out better. So heart undergoes something called as hypertrophy, where it kind of expands a bit, increases in the size a bit. The hemoglobin, which is the main postman which carries oxygen from the lungs to the cells, also increase. So if you compare the hemoglobin in a normal person and in an athlete, the hemoglobin is different, in the sense the amount of hemoglobin in an athlete is higher compared to the normal person. So naturally, more the postman, more is the amount of oxygen that can be carried from the lungs to the muscles. So that's how the circulatory system adapts. There are other things also which circulatory system does to modify itself, which is there in this diagram, but I'm not going into too much of depth. So as teachers, we should be aware that the iron supply, or the iron, is enough in the diet of your students, because hemoglobin is made up of iron. The basic material is iron. So if iron is deficient, then automatically hemoglobin will be less. Hemoglobin will be less, then oxygen carrying demand and supply will not be met. So iron should be adequate in the diet, especially in your teenage students who are undergoing menstruation or have a heavy menstrual flow. This should be a very vigilant point that you should know of, that in such students, the iron levels can fall below normal levels, and then they will feel tired and fatigued all of the time. So that is about cardiovascular system. As such, to increase the capacity of cardiovascular system, there are very specific interventions which I would not cover in this preliminary class. But if you do high intensity, short duration workouts for your respiratory system, if you see the graph which is there below, you'll see that both are increasing at the same, the slope is the same, or the curve is the same. So respiratory system and cardiovascular system go in hand in hand. If you train your respiratory system, automatically the postman will train itself to carry more oxygen and nutrients. So that is about respiratory system. Now, very two important factors that are directly linked to your cardiovascular system, respiratory system, and muscular system are the age and the sex. Okay, these two systems are directly linked to the first one. That's why I've taken them prior compared to the other variables. So as we all know, as a person ages, and since in the topic age and sex were also mentioned, so I've just taken up this point. As a person ages, the capacity of the respiratory system, the cardiovascular system, and the other muscular system decreases over a period of time. It is said that from the age of 18 to 80, there is approximately a 50% decrease in the capacity of these systems. So because the systems that govern your flexibility or govern your performance in a sports event are naturally decreasing because of aging, automatically the ability as to perform high intensity sports or sports that involve too much of physical manipulation automatically decrease with age. Of course, with age, there are diseases also that come up in cardiovascular and respiratory system, which also inhibit or which also kind of constrict a person's performance, like asthma or heart failure or other atherosclerosis. These all diseases kind of decrease the capacity of these systems, and which in turn affects the capacity of the muscles as well. But one thing which is very important over here, which we usually don't know, is that in old age, if the person is trained properly, like right after the age of 40, 45, if the person is kept in a proper training and a physical routine, etc., then the skeletal muscles, that is the muscles of the body, though cardiovascular respiratory system might decrease, but the skeletal muscles are not bound or not compulsorily decrease if they are properly trained. So if some strength exercise, some walking, some physiotherapy, some yoga practice is kept constant as the person ages, the capacity of the skeletal muscle can be maintained as it was in the adulthood, like 40 or around 45. It can be kept constant for a very longer period of time. It can even be increased. So if a person at 50, 55 has no physical regime and all that stuff, is very lethargic, fatigued, etc., if you slowly introduce these exercises, though the cardiovascular and respiratory system might not become optimum, but the skeletal muscle will adapt itself and the person's muscles will start performing better. Sex. So in this study was conducted, that's why I've put asterisk mark in the first point. This study was conducted in marathon runners. So this study, and which is applicable to other long-term sports also, that the female of capacity in a marathon, longer distance marathon, was approximately 2/3 to 3/4 of the same age male. Okay, this was that is 60 to 75% compared to the same age male. Okay, but there are exceptions to all rules. This was for marathon. It might not apply to other sports as well. But this is mainly because the number of muscles, the muscular mass or the amount of muscle is in a female is lower as compared to a male. Okay, because their natural physical build is such, because of the hormonal variation, that a male, because of testosterone, automatically has higher amount of muscle compared to female, and this muscles are spread throughout the body, even in the heart, even the diaphragm. So all the movement based organs, the amount of muscle in male is more as compared to female because of testosterone. So naturally, because the muscle is more, the activity, power, strength, power, and endurance is more. Flexibility is not out of question over here, and that's why the performance of male athletes was better in marathons as compared to female athlete. Now, in females, there is another hormone. Raj Panda ji, it's like thoda estrogen, female counterpart hormone is estrogen. Estrogen is kind of a hormone which promotes fat accumulation in the body. So in another study that was done in swimming, okay, long distance swimming, where people cross seas and people cross oceans, females performed better as compared to males. The reason being is because there was more fat in the female internal organs compared to males. This fat gave energy for a longer period of time compared to males. So that's why I put asterisk marks in both the points, the first point and the fourth point, that this is a variable thing, but age, the sex of the person does definitely affect the sports performance in various kind of sports. Okay, coming back to hydration. So first 3 points we have discussed. Age and sex were related to first 3 points of respiratory system, musculoskeletal system, and cardiovascular system. So that's why I took age and sex immediately after that. And now we come to more other points like water, temperature, and all that stuff. So hydration, that is the amount of water in your body. So if you study journals on sports physiology, there is like enough evidence to prove that if your body loses a percentage of water, like if you lose approximately 3% of your body weight, so if a person is suppose 100 kgs and because of intense exercises he has lost around 2.5 to 3 kgs of sweats because of sweating, okay, then his physical performance in that sports can considerably reduce. And if this becomes like 5 kg or something of that sort because of excess of sweating, and it happens, we are not aware of it, but it happens when there's too much of sweating, then the muscles can go into cramps, fatigue, and all that stuff as well. So the amount of water that is present in your body is directly related to your sports performance in that particular competition. So, especially in hot and humid climates, there is excess of sweating. There is excess of sweating that happens, and the athlete loses too much of water even in 1 hour, 2 hour period. And kind of the athlete doesn't know because he is in that state of performance and thinking and stressed because of the performance and the competition ahead. But the body is feeling that need. So thirst is not there, but body is still depleted of water, and that can considerably reduce his or her performance in the competition. So as coaches, you should be vigilant about the amount of water that the athlete has to take during the competition, before the competition, after the competition. That is a very important point that we should be aware of. Similarly, sometimes as teachers, we kind of over prescribe water, that drink every 15 minutes, every 30 minutes, without thinking what is the temperature, what kind of clothing the athlete has worn. All these things also have to be taken into consideration, and how we have to take into consideration, we'll discuss in the nutritional hydration lecture. So these things, but if you overhydrate, if you take too much of water, then what is required? First, urination becomes a problem. The athlete will feel the need to urinate, and the brain's attention will shift to clear the urinary bladder rather than the performance and all that stuff, because the urinary bladder will continuously send messages to the brain that I want to be, you have to empty the bladder. And secondly, in the blood, there is a particular concentration of various minerals, hemoglobin, oxygen, and everything. So if this is maybe my jar and it has 1 liter of water, and there is some concentration of sodium, potassium, chlorine, all that stuff. If I keep on adding water to it, if it becomes 2 liter, then this concentration will get diluted, and the body's performance is very, very strictly monitored by this concentration of various minerals and ions. So overhydration also has to be prevented. Okay, and how that is done? People usually, thirst is a parameter, color of the urine is a parameter. Many things are there which we'll discuss in the hydration. So as coaches, overhydration as well as dehydration have to be prevented. A person should just be hydrated, not the extremes of it. Minerals. So minerals are basically, today we are just discussing three major minerals as an overview. In nutrition, we'll discuss in detail. So calcium and phosphorus are the minerals that are directly linked to the muscular performance. For muscle to perform better, calcium is the key ingredient for muscle contraction. So any decrease or increase in calcium directly affects the muscular performance. So especially if you are working in a metropolitan city, or where your students don't have much exposure to sunlight, or they don't take, they are more into fast food and all that stuff. So instead of green leafy vegetables, milk, eggs, etc., then in such students, it's but obvious that the calcium would be deficient, and this directly affects the muscular performance. And the second mineral that goes hand in hand with calcium, that's why I've included it in one point, is phosphorus, because things that are rich in calcium usually are rich in phosphorus as well, with few exceptions here and there. So calcium and phosphorus together hamper your bone growth, in the sense bone development, bone repairing, muscular performance. And phosphorus, if we go, has other roles in the body also, because the energy currency of your body, which is called as ATP, adenosine triphosphate, which is the main energy source of your body. That is nothing but made up of phosphorus. So calcium and phosphorus, both hand in hand, definitely affect your muscular performance. So you should be very vigilant that these are supplied to your students on a daily basis, if they are performing for a competition or not, if they are in growing age group or they are adult. This should go to them in daily in the prescribed amount in some form or the other. So that is calcium and phosphorus. Apart from that, the general minerals, that is the sodium and potassium, are also equally important. Now just visualize that there are two chambers that are connected to each other. This is the muscle chamber and this is the blood chamber. There is a concentration of these minerals in both these chambers. Okay, X and Y concentration is there. Now body has to maintain this concentration as it is for its peak performance. If this concentration decreases or increases, the body cannot perform at its optimum functioning. That's why body makes all the adjustments that are required to keep this sodium potassium in a proper level in the blood. So it will manipulate the urine production, it will manipulate the sweating, it will manipulate the amount of water you drink, everything the body can do to maintain these levels constant. So as teachers, if you know that your uh, student is sweating a lot because it's summer or because anything of that sort, maybe he is performing for a longer period of time because competition is near, you should make sure that some amount of salt, either in form of lemon water or in form of any healthy drink, natural healthy drink, some amount of salt should go in his or her body at regular intervals before and after exercise. Okay, more as compared to a normal student or a normal person who is not into sports, because these people are excreting a lot also in sweat. So more amount of salt should be supplied. So that was about sodium and potassium. And this also becomes very important if you are if you are you're training in a colder part of the world, and for a competition you are coming to a warmer city or a warmer state or a warmer country. So you are not, as students, they're not sweating that much in that colder part of the world or maybe in the winter season. But when they are coming to a warmer part of the world or the season is changing to summer, you have to be vigilant about these salt requirements, water requirements in the body, as well as you have to give some time for the body to acclimatize. This is for actually for very high intensity sport, but even in other cases also, acclimatization by diet is very important. Your body should get all those requirements of salt and water, even if the climate or the place is changing. Body temperature. Now, body metabolism. Whenever something is happening in the body, when the muscle is contracting, or like uh, like we just saw that the amount of blood that is circulating in the muscle increases exponentially, sometimes about 25 times than what is in the resting state. So when so much of blood supply is increasing, definitely the metabolism of the muscles and the cells is also increasing. And when the metabolism in the cells increases, the amount of heat that is produced by the body also increases. That's why the temperature, if you touch my skin right now and you touch a skin of the person who has just performed some exercise for 1 hour, 30 minutes or so, which will be warmer, his or her skin will be warmer compared to mine, because body is generating too much of heat. Now this heat is generated because of muscle contraction. This heat is generated because the friction that is happening in the bones, the friction that is happening at the joints, the friction that is happening between the blood and the arteries and the veins. So there's lots of friction that is happening in the body when you are doing any sort of exercise. So apart from the metabolism, this friction also increases uh, the heat production in the body. And this heat, because it is generated, there are two things that happen to the heat. Some amount of heat is thrown outside into the environment through the skin, and some amount of heat goes into the tissues. Okay, so when your body is properly hydrated, I'm stressing on 2 points over here. When your body is properly hydrated, then it takes care of the internal heat, because water is cool in nature. It kind of cools down the internal organs. So whenever you're drinking water, it kind of reduces your internal body temperature. So hydration takes care of that. When you supply water it also manifests itself in sweating, and that sweating kind of cools down the temperature from externally on the skin. So hydration takes care of both the things, the internal heat, that is by reducing the core body temperature, and the external heat by sweating. Both are taken care of by hydration. So sweating is something that takes care of external body heat. Now on a hot and humid day, okay, this sweating is not working that efficiently. You know that in summers or in rainy seasons you sweat more, but still your body is not able to cool down itself. I hope you know the mechanism of sweating, how sweating works. So if you have seen an earthen pot where we fill water and we drink water basically in India, what is the mechanism? How the water inside cools down? Because of sweat, because the earthen pot generates small droplets of the water on its external surface because of its porosity. And when this water evaporates, it kind of cools down the internal temperature of the water inside that earthen pot, the matka which we have. Same happens in a body. The sweat that is generated on the skin, because of the heat, it absorbs heat and it evaporates, like it goes into the atmosphere, and when it evaporates it kind of cools down the skin temperature. That is the mechanism of sweating. But on a hot and a humid day, this evaporation decreases, body is sweating, but the sweat is not drying, it is not being absorbed into the atmosphere. So the capacity or the effectiveness of the sweating decreases in hot and humid um, climate or a city or season. So as coaches, we should be vigilant that if there is a change of climate from winters, we are entering into April, May, June months, and there has been increase in sweating, but the body temp and competition is near, you're performing more as compared to normal days, then you should take care that proper hydration is reaching your students. Second, acclimatization. If there is instant change in the climate because of traveling, then 1 or 2 days are required for the body to adjust to this new environment, new climate. So that scope also should be given. Ventilation in your training hall or in the competition hall, there should be good ventilation so that when air passes, it kind of takes away the sweat into the atmosphere. It dries up the sweat and the body is cooled down. And proper clothing that absorbs sweat and it doesn't allow the sweat to remain on the body, it absorbs sweat. Such kind of clothing should be used so that the body temperature is maintained. Otherwise there are chances of heat stroke, etc., during competitions or in summer season when there is intense heat, because the body temperature rises exponentially because of excess of metabolism. So these things need to be taken care of. There is one more point which I have not made a slide of because I thought whether I'll be able to cover it or not. So that is nervous system, which I mentioned in the first slide itself. There is a fourth system which I spoke about, that is the nervous system. Now, physiologically, if you see yoga as a sport or as an exercise regime, and you see other sports like gym or marathon or any other sport, there is a major difference. All these sports are governed by something called a sympathetic nervous system, but yoga as a sport is governed by both sympathetic and parasympathetic system, which many of us are not aware of. Now, there are two major nervous systems in our body. I'm just putting it very superficially right now. Sympathetic nervous system is all about anger, is all about performance, is all about intensity, is all about speed, is all about fight, flight, fear, running. All this is sympathetic nervous system. But the opposite of it, when the body is at a peaceful state, the body is calmed down, body is well rested, body is kind of repairing itself, healing itself, then the parasympathetic nervous system is activated. So yoga, by its own constitution as such, it is a sport that involves both sympathetic and parasympathetic nervous system. When you are performing as a sport, you are using the sympathetic nervous system. But when you are doing pranayam, when you are doing there's someone who's
Attitude वाला जो point है वो अब देने वाले थे मेरे को.
okay. But when you are doing shavasana which I in fact recommend as a compulsion to the practice when you're doing shavasana, when you're doing anulom vilom, when you're doing such kind of pranayams. These pranayams activate the parasympathetic nervous. It's research, it's proven. Like, I'm not bluffing. This is proven. It activates the parasympathetic nervous system. So the damage that is happening to the body. Okay, so from 7 a.m. to 8 a.m. you're doing maybe high intensity yoga and sympathetic nervous system is active, muscles are getting contracting, relaxing, and whatever damage is happening to the body, that ends at 8 a.m. And at 8 a.m. when you do Anulom Vilom Pranayam or other pranayam, or you do Shavasana or any this practice as a daily routine, it kind of sends a message to your body that intensity period is over. Now you can start repairing itself, and the parasympathetic nervous system starts taking over. But if you skip these practices, then what body as a mechanism at 8 a.m. it itself doesn't know that 8 a.m. now work is done, and now nothing more is going to happen. I have to carry on with my schedule. So body at till 8:30, 9 a.m., 9:30 a.m. is prepared that, okay, again, intensity workout should be, can start anytime. So I have to kind of keep myself prepared for it. But the moment you introduce these relaxation techniques in your regimen of schedule, that 8:15, by 8:15, the body knows that sympathetic nervous system has to now decrease. Parasympathetic repair, peace, alignment, healing has to become active, and it starts doing that process. So this is a very important point which we miss, and the physiology of this point is that all these asanas which are meant to do at the end, pranayam or asanas, were actually a signal to your body that the major practice where you had to strain yourself, stress yourself is over. Now you start repairing yourself, and then you carry on with your rest of your schedule. And parasympathetic nervous system, now in the modern day psychology, it's like one of the most important nervous systems, because it is a nervous system of peace and alignment. So most of the modern day psychotherapies now are starting to focus on activating this parasympathetic nervous system, so that the emotions, the body, and the thoughts are kind of peaceful and aligned. So yes, so this was about the nervous system, which I have not made the slide, but this was a brief intro. So yeah, I think 5 to 10 minutes we can take question and answers. Thank you. Thank you, Pavanji. I'll just start unmuting. Yeah. So Shreyas, Sudhakarji. Yes, sorry, Shreyas. Sudhakarji. You can unmute yourself. Sudhakarji.
Mittal Sahab, you are our favorite lecturer, and we have been enjoying your valuable inputs, and really we are very happy about it. My question has two parts, sir. First is about hypertrophy. You said the blood circulation while in motion. My specific question with regards to the exercise is where somebody has an average individual has a capacity to do 100 Surya Namaskara cycles. Is it better we stop and divide and keep giving the break in between, or is it advisable to accumulate more of oxygenation over a period continuously? That is the first question. And the second is a doubt. During it, in tropical circumstances, tropical areas, they have given a formula for intake of water when we are talking about hydration. The formula given is 10% of the human's weight minus 2 liters. That should be the ideal consumption of water. Can you please throw light on these two aspects?
Sure. So the first question is very subjective in the sense, if you've trained the athlete to perform 100 Surya Namaskars over the 6 months period, 1 year's period, 3 months period, depending upon his physical build, male, female, age, etc., then doing 100 Surya Namaskar at a stretch is not a problem, because it's a physiological thing. Body adapts to it. Like a marathon runner, I cannot tell him that you run only 3-kilometer marathon, you don't need to run a 12-kilometer, because he has increased his capacity from 3 to 5 to 6 to 7 to 8, and then he has reached the 10. So body has already adapted itself to give that 100 Surya Namaskar at a stretch. So body systems have adapted itself. But during the training period, when you're training him to reach that 100 target, it's but obvious that you give him gap after every 10, 15, depending how what is his capacity in the initial days, and you slowly keep on increasing his capacity from circulatory system, respiratory, and all the other perspectives. I hope I've answered this question. So it depends. Endurance has to be increased, but once endurance has reached, like military people, when they are into those trainings where they do that secret force, I don't know the exact name, commando training and all, they perform sometimes 48 hours a stretch without sleep. So their body has been trained for that for the last 3 years to sleep for don't sleep for 4 hours and 36 hours and 48 hours. So that for them, for once in a while, being awake for 48 hours is okay, but this shouldn't become a routine. Okay, your second question, the formula for hydration in tropical country, it's right in the sense in normal circumstances this formula works. But what we'll be discussing in the nutrition lecture is a form. It's not a formula. It's a very subjective analysis for sports people. Now, if a person is performing sports for 2 hours, then the same formula will not work for the person performing sports for 8 hours in that same tropical, because the loss of water is higher compared to the 2 hour sports practice. So that is this is good for normal day-to-day living, that 10% of body weight and minus 2 liters, and with some amount of exercise. But depending upon what sports you are into, that amount of water increases or decreases. I hope I have answered your question.
Thank you, sir. Thank you very much.
Yes, Shrikantji. Yeah, there are 2 people, so we can take both the questions. Yes, Shrikantji.
Am I audible, sir?
Yes, you are audible.
Yes, actually, sir, I just want to ask you regarding sweating. Just now you are explaining about the sweating. So some students are like that. So those are suppose they are having a normal, like we have a 2 kind of students, like normal students and some those who are having a more sweatings. So which kind of food we can recommend them, and how many water they have to drink in a one day? Like they are having a most, like if they are standing in a classroom and fans are not on, so they start the sweatings. So for that students, how which kind of foods and how many water they have to drink in one day? I want that.
Water question I'll answer take up in the nutrition lecture, that's for sure. Now these people have a high metabolic rate that is called as BMR. If I put in Ayurvedic terms, a higher amount of Pitta Prakriti. So they sweat even in normal as compared to a normal colleague or something. So it depends. Like there is no specific recommendation for what kind of food, but if they are facing those side effects of increased basal metabolic rate, then we give them pacifying foods. We try to increase more cooling substances in their diet so that their basal metabolic rate, though it's high, but the body is not affected by that excess of heat inside it. So we give them fennel seeds, we give them cumin seeds from natural therapy perspectives. We advise them proper cotton clothing rather compared to synthetic clothing. We tell them to have more water. We put sugar or salt as in water once or twice in a day, so that it also acts like a coolant. So we give more of a cooling substances to their body. This is for pitta pacification of that one. Yeah.
Thank you, sir.
Okay. One more question, then we can maybe Sanjay ji. Yes, Sanjay ji.
Pranam, sir.
Pranam.
Sir, I have 2 questions. One is that when we are asking the students to perform by taking the care of all the nutrition, all, I mean, some of the students will getting the cramps, and some students will be getting the consistency of the nerve system. So that will affect the accuracy of the postures. So how do we have to overcome? This is the first question. Then second question, when you make the students to little stress in the particular posture, there's a holding time and all we are increased. And the accuracy of the postures are also changing and it's affecting. So how do we have to overcome that one, sir?
So your first question about cramps and all. So if I speak from the allopathic perspective, the actual reason of cramps is the imbalance in minerals and ions. Okay, so specifically ions like magnesium and all, which we'll speak in the nutrition lecture. Sorry, I'm saying again and again nutrition lecture because then otherwise that time it will become repetitive that I'm repeating the same points. So magnesium, potassium, and calcium, these 3 ions are the major things that are affected in the cramp, the causation of cramps. So in such students, I usually tell them to take coconut water on a daily basis for the first few days, or maybe alternate days with squeezing one lemon, because vitamin C also goes in. So it's seen that the amount of cramp gets reduced. Allopathically, there are other tablets, powders of minerals that we give, but this is one of the easiest way. And the other thing is oil massage, because Vata dosh increases, pain and cramps also increase. Sorry, I'm also shifting to the Ayurvedic perspective. So some amount of oil massage, alternate days, or before taking bath, or maybe once a week or something, kind of keeps the Vata dosh pacified, and that also helps in reducing the amount of pain, cramps, and all that stuff. Yeah. Okay.
What about the second question, sir?
Sorry, could you repeat your second question?
Yeah,
sorry.
sir. Students are performing the particular posture, and if we want to increase the holding time, that's why if we want to increase the practice tense, then there will be this affecting factor of the accuracy of the posture. So how do we have overcome that one, sir?
So that is all about the strength of the muscle and the endurance of the muscle. And that happens usually we use props and everything to increase. So first, we don't allow that muscle to take the whole weight of whatever asana you are doing. Then we slowly increase the amount of it. So we are increasing the strength of the muscle. At the same time, we are increasing the endurance of the muscle, so that it takes the weight, slowly, part by part, and it keeps on adapting itself to higher weight. And if at the first time you give it all the weight, then it won't be able to sustain for 1 or 2 seconds also, because it's not adapted to it. So that's why we use props, and which I think use of props is taught to you. That will increase the holding time over a period of time. It doesn't happen at a stage, but it takes a few months or weeks to increase holding time.
Thank you, sir. Thank you. Thank you.
Time for more questions, or I don't know. We have 3-4 more hands. 3 hands more. Yeah. Oh, sorry, Aarti ji, only one. Aarti ji, yes, please go ahead.
Namaste, Bhaiya. I just wanted to ask one thing, two things actually. One, say for example, a student, children who have the limitation in their body, and if they are going for, I just wanted to understand, like when there is an training for kids to go for athletes and that level. So is that we are considering that the natural flexibility which we are increasing, or second, it's like we are actually working on their flexibility, because every person has the limitation in their muscle movements. Every person doesn't have the same flexibility. So when we are actually training the athlete, it's like some kids who are actually flexible and we are working on them to go a little higher. Is it that way? No, we are just considering that no, everybody has a capacity to go at that level and train them according to that way.
I would
So
say
this is
there's
my
a.
first question.
Let me answer the first, then otherwise I forget the second question.
Yeah.
So there is a threshold to both the things. Okay. First, till one point of time, the flexibility can be definitely be increased. But after a point of time, because of various proteins, I had named a few, fibrilin, TTN, etc. So there are many genetic permutations and combinations in these proteins, which can after a point of time, you will feel that how much ever I am doing, it's not working. There is the flexibility is not increasing. Then it's the genetic component. But every human being has a capacity to increase his or her flexibility. I don't know the number because I've not read any research paper per se on it, that how much the flexibility can be increased. But definitely physiologically, there is a natural threshold till where you can increase the flexibility of that particular child or whatever. But at a point of time, it will stop. And if even with your full efforts, it's not increasing further, then you realize that this is the threshold of the natural flexibility. Now, if anything more than that will be going unnatural. This is the easiest way, because genetic testing and all these things are not possible. Even the science is not advanced that much. Yeah.
Okay.
Okay.
And my second question is, say if you're training an athlete, so in the or whatever we actually got today, it was very informative. So according to it, it's very important for that kid to have a physical, like a cardio exercise. It can be a push-up or external body weight also it has to be, or it is just the kids, its own body weight they have to work with.
The human body is designed as such that even your internal, like your own body weight, can give it its whole required cardiological, sorry, not cardiological, the cardio workout. But if you are working specifically on strength, you're working specifically on endurance, you're specifically working on flexibility, that time you have to, for maintaining basic health, the body weight is more than enough. But you're specifically targeting competitions, then you have to definitely supplement with certain external, not too much like what weightlifters do, 5-10 kgs, 2.5 kgs. That much supplementation does help. Yeah, it kind of
Okay.
fastens the
Okay.
whole process. Yeah.
Okay. Thank you so much. Thank you so much, sir.
Yes, sir. Yeah. Sorry if I don't, Saldin ji. Sorry if I pronounced it incorrectly.
Sir, Hariom sir.
Hariom.
Sir, I have a question. There is any relation between flexibility and magnesium, sir?
Yeah, definitely. We'll discuss this. Definitely. Muscle performance is highly related to magnesium. In nutrition, I'll be like magnesium is the current day superfood for athletes, which we will be discussing on the day of nutrition. But in children, we usually don't. If you are dealing with children, low, like child or teenage age group, we don't focus on magnesium. If it's completely sports performance, then we take care of magnesium as well. Yeah.
Hariom sir,
We'll
thank
discuss
you. Sir.
magnesium. Thank you. Yes, Shreyas, I think we are done with the questions. Over to you. Shreyas, over to you.
Thank you very much, sir, for your valuable inputs. And smoothly, you have tried to cover all the doubts raised by the candidates. Thank you very much for your insights.
Thank you.
Thank you.